Hello and welcome to lesson 1.2, perfect squares, perfect cubes, and their roots. So we're going to start off with some definitions. Whenever we have a definition, always highlight the definition so that if we need to reference a term, it's easy to find on the page. So we have a perfect square number. So a number written as a power with an integer base and an exponent of 2. So an example of that, we would have 4 squared is equal to 16. We have an integer base and an exponent of 2. It's going to equal 16. A perfect cube is very similar definition. A number written as a power with an integer base and an exponent of 3. So an example of that, 2 cubed is equal to 8. Here we have a hundreds chart, but before we get to that, I would like us to look at this bottom table here. So we have to complete this table using the perfect squares from 1 to 15 and the perfect cubes from 1 to 15. So I'm going to start with filling in this table first before the chart. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and as you can see, squaring each number up this table. Now these should come quite naturally to you. They should be memorized at least up to 12 and to 25 from grade 9. Now the perfect cubes. 1 cubed is 1, 2 cubed is 8, we have 27, 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, and so on. The numbers are quite difficult to write in these small boxes. 28, 17, 28, 13 cubed is 2197, 14 cubed is 2744, and 15 cubed is 3375. Now when we look back at our hundreds chart, we can cross-reference with the table to determine the perfect squares from 0 to 100. So I'm going to circle them. So we have 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And I'm going to put an X through the perfect cubes in blue, cross-referencing with the table 1, 8, 27, 64 are perfect cubes from 1 to 100. All right, turning over to the next page, determining perfect squares. So how do we know if 40 is a perfect square? And we're going to explain that. If we look at our chart on the other page, our table, we know that it's not a perfect square, but how do we know that? So if we look at our closest perfect squares, we have 6 times 6 is 36, and 7 times 7 is equal to 49. So therefore, there's no whole number between 6 and 7. So therefore, 40 isn't a perfect square. Or you could think the square root of 40 is equal to 6.32, and 6.32 is not an integer, it's a decimal, so therefore not a perfect square. Perfect cube of 1728, so 1728 is equal to 12 cubed. So therefore it is a perfect cube. Another way you could recognize that is that the cube root of 1728 is equal to 12. So make sure you know how to find the cube root button on your calculator. It's different on all calculators, so make sure you're able to calculate using the cube root button. So we have two definitions here, the square root and the cube root. So square root, we have 2 and n, so we have a number whose square is n, compared to a cube root where a number whose cube is n. Example 3, we're going to determine the square root of a whole number. So it just asks you to determine the square root of 1296. To take the square root of that number, it equals 36. Example 4, determine the cube root of a whole number. Into your calculator, the cube root of 4210 is equal to 16.147. So therefore, 4210 is not a perfect cube. Using that knowledge and some prior knowledge based off of surface area, we're going to solve this problem using roots to solve a problem. So we have a cube has a volume, so that's a key term there, of 4,913 cubic inches. It's given us a measurement. What is the surface area of the cube? So we need to know that in order to solve for volume, it's equal to the length multiplied by the length multiplied by the length of a cube, and we know that's equal to 4,913 inches cubed. So if the length cubed is equal to this value, if we take the cube root, the length of one side would give us 17 inches. Oops. And we know that's correct because 17 cubed is equal to 4,913. Now, using this information, we need to find the surface area of the cube. If one length is 17 inches, we can recognize that the side length of a cube is 17 inches. So we have a cube. And it has 6 sides, so we need to know that. In order to calculate the surface area, we need to calculate the surface area of one side first. So surface area is length times width, so we have 17 times 17. Gives us 289 inches squared. And we know that a cube has 6 sides. So in order to determine the surface area of the whole cube, we're going to multiply that by 6 sides to give us 1,734 inches squared of the surface area of that cube. The practice problems that go along with the textbook for this is page 146 of the textbook. Questions 4, 5, 7, 8, and 12. That is all for this lesson 1.2 for today.